Hi everyone, and welcome to the Risk Awareness Week 2020. It is a great pleasure for me to welcome Brian Putt, and this is one of a few sessions that we'll record with Brian together. I'll tell you a little bit more about the session in a second, but I wanted to give the word to Brian to introduce himself and talk a little bit about what his experience in risk and decision analysis has been.
No, thank you, Alex. I spent several decades working at Chevron, and in several of those decades developing the decision practice at Chevron, which grew to about 230 people when I left. It was all worldwide. Since then, since retiring, I've been kind of volunteering my time, working with nonprofits, doing videos, developing a YouTube channel. So let me put in a plug-in for Society of Decision Professionals and what they can offer for people that are interested in risk management and decision analysis, decision quality.
Yeah, and actually, let me just pick up on those 2 points before we move into this specific workshop. Brian has an amazing YouTube channel, so you just search on YouTube for Brian Putt, plus underneath this video there will be a link to the YouTube channel, and Brian has a lot of very small, concise, and nice educational videos on certain kind of key techniques in decision analysis. And the other important point is for individuals that want to learn what I call risk management too, but what in reality is called decision science, and the techniques and the methodologies and the practices and the case studies, and talk to like-minded individuals. SDP, which is the Society for Decision Professionals, is the place to be. I'm a member as well, and this is a little plug for the organization, because they are doing an amazing job trying to kind of populate and promote the quality, the better approach to decision making. If you work in risk management, this is what we would call risk-based decision making. The irony is that the decision professionals have called it decision science probably 100 years earlier than we decided to call it risk-based decision making. So if you want to look at at the source, at the origins of good risk management, then SDP is the place to be, and Brian's YouTube channel as well. So for today, for this workshop and for the next workshop as well, what we wanted to do is we wanted to see if we can improve our life day-to-day decisions using good decision quality framework or decision analysis, as well as risk analysis. And we've picked a case study that would be applicable to every single person that is watching us right now, something that you can relate to in your day-to-day life. And that's a decision that we have to make when we need to travel to the airport, and the choices that we have, and the pros and cons of alternatives, and how we normally make that decision compared to what a quality decision framework would look like. So I've asked Brian to help me basically make that decision, and we've used the case study of me having to travel from my home in Spain to Barcelona airport to fly to my work in Switzerland. The destination of where I'm flying doesn't actually matter, because the decision that I'm trying to make is, how do I get to the airport in the most effective way, accounting for the risks, accounting for uncertainties, accounting for all the different variables. So, Brian, over to you. What would be the first place to start? What are some of the important messages that I need to understand before I make this decision?
Well, Alex, first of all, let's be very clear. In this case, I'm going to be the analyst working with you, the subject matter expert and the decision maker. And so we'll work from those two roles. And we did have a conversation about this in general, about what the frame might be. And I thought what we might do is look at the frame. The frame is really one of the most important things to do at the beginning of a study. Mm-hmm. So let me share my screen. I want to share just one slide here. So this slide actually comes from Chevron, and it was presented at the 2020 Decision Analysis Affinity Group meeting, or DAG meeting. You can look up DAG on the internet. But basically what it's showing is that where is the value in your decision? The value is not in, the good execution over here. It's really in the framing session in these first few sections, or they call them chip dip phases at Chevron, where you're trying to identify alternatives. If you don't identify good alternatives here, we can't get to this upper level where we have the good value. Mm-hmm. So let's go through the framing process, and it's a structured process, Alex. And you can, this applies to whether it's going to the airport or talking about $1 billion project. You have to have a good frame as the foundation. Okay. So now let me share my Excel model here, and we'll start here with the traveling to Barcelona. Maybe I can make that a little bit bigger for us to read.
Yep.
Okay. So we need to make sure we agree on the opportunity statement. So what we said is, what is the most efficient way to get to travel to the Barcelona airport and then return home? Mm-hmm. And the concept here would be that you might return home differently than the way you got there in some cases. Okay.
Yes.
And then there's some boundary conditions we talked about, which is the flight that you want to take is at 5 p.m. Mm-hmm. And I think you've said that's the only one you want to use. There's no other alternative, right? So we have.
Yes, yeah, exactly. Okay. I mean, that's the one that I purchased. There are probably alternatives, but that's the ticket that I have.
Okay, all right, that's fine. And then we were in this worldwide situation where we have coronavirus going around, and that may have an impact on us. So, and also, I guess there's a personal issue is that you don't drive. So we have to work around that one, okay?
Yes, exactly. So driving my own car is not an option, but I have other options.
All right, super. So now the next thing, after we've done that, we're going to bring, in general, we would bring all the subject matter experts together. You being the only subject matter expert, you're the only one I need. Yeah. So we'll go over here and we'll talk about issues. And this issue raising can be done lots of different ways. And whatever the facilitator is most comfortable with, or the subject matter experts are comfortable with, that's what you should use. But anyway, you need to get this list, just kind of brainstorming. And we generated this list of things here. Talk about what are these are all uncertainties with the U's. So these are all uncertainties. There's a major decision here what mode of transportation to use. And I guess this is really transportation to use to the airport. Mm-hmm. Right? And do we want to look at the transportation coming home as well?
Yes, of course.
Okay, so I'm not sure we handed that one. So let's see. What mode of transportation to use returning from airport? Mm-hmm. Right. Then we have value measures, effective use of my time. So you're going to identify an hourly rate that you're going to assign to this, because the longer it takes you to get to the airport, there's got to be some utility to that, right?
Exactly.
Shorter time, yeah.
Yeah. And then is that we discussed. I mean, they're kind of the obvious is the cost, the distance, the traffic, the weather, the availability of my wife to actually drive me to the airport, the condition of the car, etc., etc. All of those things that are uncertain in making this decision.
Yeah, those are uncertainties. I certainly agree with that. But we need to talk about the value measure. What am I trying to maximize or minimize in this case, perhaps? And I think we're trying to minimize the cost, right? And part of that cost is the time that you spend and your hourly rate applied to that time. And if you want to apply different rates to different parts, that would be fine. But we might want to keep it simple to start with, and then we can expand on this. I mean, it's there's a cycle to this, and there's a recycle available as you do the analysis and learn more. Okay. We have some weather that's included and so forth. Then we had some sensitivity analysis. So these are the things we identify. Is there anything else that you thought of since we last talked about this problem?
That's a good question. In terms of other factors, observations, shall we maybe include how sensitive we are to the time of the flight? Shall we even touch on that? Because that is, I mean, in a way, that's kind of a perfect example of narrow framing, because I've given myself this fact that my flight is 5 p.m. But what if our analysis shows that I can spend half the amount of money on traveling to the airport if I were to take an earlier or later flight? And that would kind of overall, on the cost of the transport of the whole trip, that would actually be more economically viable. So I don't think we necessarily need to reframe the problem right now, because I mean, I'm still interested in specifically talking about getting to the airport, disregarding the next journey. But this is a perfect example of how sometimes we just artificially narrow our options and kind of miss the whole conversation.
Well, I would suggest, we're probably going to go through this analysis a couple of times. And so why don't we keep that on the back burner? That we've got that highlighted here.
Yep.
Maybe I'll just put a note here. Might want to consider alternative flights. Clearly, maybe for the time being, we can assume that all the flights cost the same. It's just a matter of getting there, because I think some of the options we talked about were taking a bus and public transportation, and there's limitations on that as well, so which you can't change.
Yeah.
So, yeah. Okay.
Exactly.
All right. So,
and by the way, just for everyone watching us, if you're looking at this list of uncertainties, and if you can think of anything else that you would add as an uncertainty to this overall model, just write in the comments underneath, and then we'll chat about it in the comments.
Oh, then we have to redo the analysis, Alex, eh? Okay. All right, fair enough. So after we've done all this brainstorming, we want to sort out those decisions. And so we've brought the decisions over to here. And there were some givens. And that was the flight leaves at 5 p.m., which we're going to maybe come back and reconsider.
Yep.
The virus is going to be with us, and you don't drive. And so the question is, what mode of transportation to use to the airport?
Yep.
And then there's what mode of transportation to use returning home. Okay?
Mm-hmm.
So those are the things we want to decide. And then we didn't come up with any tactical details. These are the things that we could decide later. Okay? I'm not sure what those are at this point, but this is kind of a placeholder to make sure everything gets concluded.
Sure.
Because one of the things you want to do in a framing session is be inclusive of all your subject matter experts. You don't want to say, hey, you don't know what you're talking about. That's not important. We're not going to consider that. So you want to make sure everything gets considered someplace so they feel like they partially own the analysis. Okay.
Mm-hmm. Mm-hmm.
Now the rubber meets the road, if I can use that phrase, when we get to the strategy table.
Uh-huh.
What the strategy table is going to do is to bring these focus on decisions over to a table where we are going to identify different alternatives. And this strategy table can be turned this way or it can be turned 90 degrees, however you want to think is the most economical use of your screen or a piece of paper you're going to print out or whatever. So, so here was what mode of transportation to use getting to the airport. And we identified that your wife could drive you.
Yes.
Assuming she's available, of course.
Yes.
So that's a constraint. You could take the bus, And that was a bus all the way to the airport?
Yes.
Okay. Or you can take a train. And I think the way I understood the train is you maybe have to take the metro to the train and then the train, or maybe
it's not a direct train. I have to change.
Oh, okay.
Yeah.
All right.
Change to metro, and my wife still needs to drive me to the train. So there are some minor complications there.
That's three modes of transportation at least there.
Yes.
But
with a smaller leg compared to
at least with an uncertainty associated with it too. So
yes, true.
And then we have a taxi that you can take. You know, in other locations, like when I did something similar to this for my going to the airport, you know, I had an Uber involved, but you don't have an Ubers there. You have a taxi, so that's fine. Any other alternatives that you can think of?
That seems. I mean, you know, a bike and walking are the alternatives, but the distance is 100.
No, okay. So one of the things we need to do is when we talk about alternatives, they need to be reasonably feasible. Okay. Don't let the decision maker rule something out because he has one answer, one decision that he wants to make. Don't let him rule it out that way. But things like walking, if it's, you know, it's a 3-hour, 4-hour walk, obviously you're not going to do that. But one of the things you might think about here is your wife's not available to drive you, but you really like to take the train. You could take a taxi to the train.
True.
So the taxi doesn't have to go all the way, right? So this could be taxi to the airport.
Yep.
And then there could be a taxi to the train or bus station.
Yeah.
Okay. All right. Anything else that we can think of here? We want to make sure that we, okay.
Yeah. If anybody's watching us has any other ideas, write in the comments.
Okay, great. So now, right now we have our flight at 5 o'clock. And the question is, you know, people will have different risk tolerances for getting to the airport. So I think what we talked about was maybe a 1 hour, 1.5 hours, or 2 hours.
Yes.
Right.
So get to the airport before the actual flight.
To get to the airport before the actual flight.
Yeah.
Right. And obviously this depends upon you know, luggage and everything else and how complicated the airport is and so forth. So, but that's a personal decision that you're going to have to make. And then what mode of transportation to get home? And these are probably the same ones, I guess.
Yes.
So we'll just take those and pop them over here. Okay.
Mm-hmm. So
and then I think
it's just the last one is just in reverse: train and then taxi.
Down here.
Yeah.
Okay. Taxi from, right?
Yes, exactly.
Okay. All right. Good.
Do these colorful icons mean anything?
Well, the idea would be to come over here. I kind of use a template. I'm not sure what happened here. I guess so there's an icon. Okay. We could identify some scenarios here. So we might talk about what is the fastest. You're running late, because although you're thinking about the 5 o'clock and that's the ticket you've purchased, I'd like to think about this analysis as applying to all of your flights. Okay. Mm-hmm. And we could say it's always 5 o'clock, but you could be running late one morning, one day, and you need to take the fastest route. It may not be the cheapest, but you need to get there. And then you might look at the cheapest route. Okay.
Yeah.
What other kind of scenarios can we think of? We got the fastest route and the cheapest route.
Most comfortable.
Most comfortable. Okay. All right.
Oh, I see. So each of those themes would have a symbol, and then we can kind of select which of the options would satisfy that scenario.
Generally so, yes. And what I like to say at this point on the strategy table, when decision analysis first started to get rolling, at least at Chevron, I'll say, and that was the early 1990s, you know, the computers at that point in time weren't very powerful. And so you really had to, I like to say, trim the tree by coming up with these scenarios. Oftentimes now with computers as fast as they are, you can look at all the alternatives. But let's so what will be the fastest if I wanted the fastest, which of these alternatives would be the same, would be the fastest or nearly the same?
Well, the fastest would be, and can we select more than one?
Yes, yes.
Wife driving or taxi.
Okay, so we'll do it like that. So what I've done is said this symbol here,
Yes.
what is the fastest corresponds to this and that. Okay,
Yeah.
It wouldn't be the bus or the train for sure, right?
Yes.
And then if she drives you, does this matter?
Yes, and the fastest would be to arrive just 1 hour before the flight.
Okay, that has the, okay. What if the check-in line's long and whatever? Would that impact you? I mean, I understand that this is the fastest, but I would think that this is more of a risk tolerance on your side.
Yeah, well, if we need to select anything from this column, then it would be 1 hour. But if it's just because it is our risk tolerance, if it's our risk tolerance, then we don't need to.
I think we'll probably look at all those. So it would come down to what time do we leave the house?
Yeah.
Right. Yeah. Okay. And what mode of transportation to get?
It's the same. Wife drives me and taxi.
Yeah. Okay. Fine. So we'll take that one, copy it, and put it down here. Right. So there'd be those combinations and not. So this let me just kind of move these guys out. They're not. They haven't been assigned those. Okay. The cheapest route. What's the cheapest route?
Cheapest would be bus.
Cheapest is the bus. Okay. And the cheapest over here would be the bus, clearly. All right. And then the most comfortable.
Most comfortable is wife driving and taxi.
Wife driving and taxi. Wife driving. Okay. And taxi.
Yeah.
Wow.
I mean, I was going to say taxi is the most comfortable, but just in case she watches this video, I'm not going to say that.
Okay. So I guess the question is, why would you ever take the train? What is the argument for taking the train?
Bus has limited. So if nobody is able to pick me up and I don't want to pay for the taxi, bus has a very set time frame schedule, and if I miss one bus, the next one is in like 2 or 3 hours. So I like not have a choice. But
so how frequent is the train?
Well, the metro is every couple of minutes, and the train is every half an hour.
Okay, the metro is different from the bus, right? So this is a train and metro?
Yes, train and metro, yeah.
Okay.
Well, yeah, it's the bus is every 3 hours. The train and metro is every half an hour.
Okay. And the bus is every 3 hours?
Yeah, just for the sake of this analysis, let's use that.
Okay, that's fine. That's fine. I want to make sure you gave me some information. I just want to make sure I capture it in our frame, so it gets referred to, because clearly that kind of constrains you on when you're going to get to the airport, right? And actually, we're going to probably have to get to the times of these buses in order to really do the analysis, right? And so really, when we talk about the cheapest route, we better talk about this being as well here. Let me ask another question. What about one of the things we talked about was the putting a value on your time. So is the bus and the train equal time getting there?
Let me. I think bus is slightly longer, but they are similar. I need to look it up, the exact numbers, but I think they are. Yes,
Okay.
they are.
I mean, I'm just saying that's become a factor as well in which way you went here.
Yeah.
So one of the things we've been doing here, Alex, is I've been kind of stretching you on the alternatives that we should be looking at. Right. Okay. And then I guess this button here also goes over here, because one of the things after you put together these alternatives, this is where I said the rubber meets the road. You know, if you come up here and you know none of these, if one of these boxes doesn't have any symbols at all, then you have to ask the question, well, why am I considering that? I don't need to really do that analysis. I can just drop it out altogether. And this, we don't have any symbols here, but we've said we're going to really look at all of these in some sense, right? Oh, I guess we have taxi and train or taxi. So this is really the same.
Yes.
And maybe I'm being repetitive here, but I'll put some boxes around that and some boxes around this. Okay. All right. Very good. Whoop. And then that's stretched. Whoop.
That's fine.
Yeah. Okay. All right. So we did briefly chat about come here, some cost components. And we kind of broke it out into the costs and time dependent. And then there were some common uncertainties. So the common things are going to apply to every one of these alternatives. And this hasn't been updated per se, but so the value by time, traffic, weather, the coronavirus. And so I think that's fine. What I'd like to do now is to say, well, we have an influence diagram. I haven't put that together, but I think we did that because basically you've got these alternatives, you know, to the airport, and then there'd be similar ones coming home. But then there's a whole bunch of uncertainties underneath it. I mean, this is not a particularly complex problem. It's just a matter of this. What we're really doing here is collecting all these different types of information, all these different types of risks, and trying to bring them together into one analysis. Okay, that's where we're trying to go.
Shall we attempt and build the influence diagram together?
We can. Let me take these guys, and I'm going to move them all over here. I don't know. So we have something over here. So we have the these are the common ones. Traffic, weather, and hourly rate. Okay, so they would apply to all of them. And so,
yep. So we've added the fifth one, which is taxi plus train.
Okay, taxi plus train. And these assume the wife drive you. Is that correct?
Sorry?
The train and the bus assume that your wife drives you to those locations?
Yes.
Okay. And I guess, yes, right. Okay. So, all right, let's come back to our issues over here. Here's first one. Costs associated with each journey. Well, that's going to be pretty general. Distance to the airport. Okay. So we'll come back over here to influence diagram. And by the way, this is something I oftentimes what I do after a framing sessions, I would then go home that night and build this and then bring it back and kind of review it. But this is distance to the airport. Okay. I think there's another one which is the petrol cost.
Yep. And the way distance to the airport is uncertain is because there are a number of routes. And it's a balance between kind of taking a shorter route with more traffic potential or a longer route with less traffic, even in the car or taxi.
So from a practical perspective, your wife is driving you. Do you use a Google or Waze or something like that to decide which route to take?
There are at least 5 different routes to take. And we would actually like that. That's why I think it's uncertainty. It's not a guaranteed.
No, I agree. But what I'm telling you is that how are you going to make that decision? I mean, that's not a decision we're going to make here. I mean, that has to be a real-time decision.
Yes,
right?
of course. Yes.
And so how are you going to do that?
We would look at the Google Maps and the traffic forecast.
Okay. All right. So the petrol cost. And if you're driving your own car now, what is your, I think you want to work in kilometers per gallon, right?
Consumption, yeah, petrol consumption, yeah.
Yeah. Mm-hmm. Well, we're going to take the distance and the petrol cost and the kilometers per gallon to get the total cost there, right?
And the tolls.
Oh, and the tolls, okay. Tolls. All right. Let's see what else we have here. Condition of the car. I'm not sure how we're going to do that one, but that's all right. Roads closed because of coronavirus. Oh my goodness. Really? We're going to do that, eh?
Well, I mean, that's kind of a subset of distance to the airport. Because if some roads are closed, it's just the distance becomes a lot bigger.
Okay, so we'll incorporate that. We're going to incorporate that one. We'll considered in distance uncertainty to airport. Is that what we're saying there?
Yep.
It's going to be kind of all inclusive?
Yes.
Okay, all right.
I mean, we may later go fancy and just simulate as a separate, probabilistic event that roads closed, hence add 20% to distance.
Okay. You want to do that as a separate second cycle or something, though?
Yeah.
When hearing you say.
Just as.
Okay.
Just
fine.
to kind of have fun with SIP math when we get to it later.
Sure. Just because we haven't mentioned SIP math before. SIP math comes from probability management, and there's 2 versions. One's a free version, and one's an enterprise version that you can purchase. But,
and this is what we will intend to use later in the next session when we actually build the model around this problem and see how we can simulate different assumptions and what kind of decisions we can make.
Right. So maybe that's probably pretty good for that one.
Mm-hmm.
So then we have the I guess I should put some lines in here. Tell you what I'm going to do. I'm going to put a line right down here, and then we'll kind of take all of these guys and move them over, because I think this one's going to these are going to apply to this one as well, right?
Yes, pretty much.
Pretty much the same, yeah.
Maybe the petrol consumption less so, and the petrol consumption would be replaced by the taxi tariff.
Sure. So let's tell you what we'll do. We'll put a taxi tariff here. We may have to spread this thing out a bit, right? We'll bring in a taxi tariff. And that'll be a function of which route he takes, I guess. And
yep.
So we'll But let's not take the time to do this, but there'd be all these lines coming down here.
Mm-hmm.
And that one, we only apply that one.
Mm-hmm.
The petrol cost would go to petrol, but not to the taxi, right?
Yes.
Yeah. And then there'd be arrows down here as well. Okay. So then for the train now, we have the train cost.
Mm-hmm.
We're gonna have I'm thinking of this in terms of, okay, there's a physical cost, the dollars you have to pay, but then there's the cost for your time. And so I'm gonna put the time here, transportation time.
Yep. And the train has the train cost and the metro cost. And the
Oh, okay. So we got a metro cost here as well.
Yeah.
Right, okay.
And there's also, because we're using two modes of train, metro and train, there's another uncertainty around connection time.
Okay, we'll do, so these will be the physical time for the train and the metro, but then there's the connection time here as well.
Mm-hmm.
So we don't forget that, right? Okay. And these are not impacted by traffic, whereas let's see, I guess I really want this to go up here. Now, actually, the Alex, in framing this thing, the direction of the arrow is important.
Mm-hmm.
It says, and maybe we need to talk about this particular one of traffic, but typically what this says is you make a decision that your wife's going to drive you, and then you learn about the traffic. Mm-hmm. If I had turned the arrow around, okay, then it would say I learned about the traffic, and then I would make a decision on whether to do my taxi or the train. So for example, let me give you an example. Let's say that the weather is just terrible, the roads are all blocked because of coronavirus, there's accidents all over the place, it's going to take 2 or 3, twice as long to get there by road. Uh-huh. So at that point in time, you see, I learned about the traffic, and then I might make a decision to go by the train, because the train would be not impacted by all that.
Yes.
Okay. So the direction of these arrows matter. But I think what we're going to do here is probably do them that way for the time being. No, excuse me, the other way around, but wasn't it? We're going to make a decision, and then we're going to find out about the traffic.
Yeah, because I mean that's probably how it will normally happen.
Yeah. Right. Yeah. Yeah. Okay. And then the bus cost, we have the cost.
Yep.
Right. And then we have the time here, transportation time.
Yep. Which actually depends on the traffic as well, because it's on the road, just like the car or taxi.
Sure. So we'll put a line from the bus over there too, right?
Mm-hmm.
Okay. I mean, we said these were kind of common. I guess the traffic and the weather probably don't impact the train too much, but because the train also requires the metro, right? You got to keep that in mind, /metro. Although the metro runs on tracks, right? And not in the street.
Yeah, it's on the ground.
It's on the ground, but it's not running through the streets. I mean, like in San Francisco, we have metros that run on physical streets as well, and there are tracks in the middle.
No, it's completely independent from the actual traffic on the road.
Okay, very good. Okay, and then taxi and train is really a combination of these things, right?
Mm-hmm.
So taxi and train. So the but this is a different taxi cost. This is the
Small, yeah, exactly. Yeah.
taxi cost to train station.
Yes.
Right. And then there's the time associated with this. Time for, you want to do the for taxi and train ride.
Mm-hmm.
Now, this has really got, the train here has also got the metro, doesn't it?
It does, yes.
Yeah. No, that's a complicated one, I'll tell you. You really want to consider that, eh? Okay, fine, we'll do it. I have a different utility function for this. I'm not going to do 3 connections.
Mm-hmm.
So, all right, I don't know that we really want to take time to put all these arrows.
It's actually going to be interesting because maybe by doing train metro, we will realize that it's not a viable option with very few, like with only few exceptions, and then we wouldn't even need to calculate train plus taxi.
Mm-hmm. Mm-hmm.
Maybe, I don't know.
Yeah. I think this comes into the point where you get some information ahead of the trip, okay, such as, okay, really bad weather, roads are terrible, and so forth. You make that decision.
Yeah. Which is, but by the way, what kind of quality decision making is all about? It's understanding what conditions have to be true for you to even consider a certain mode of transport.
Right. And I think as we go through the analysis, there's going to be some things I think that we're going to see in the CDF, the cumulative distribution chart, where there's something, so maybe some breaks. And those could be the binary variables that we have about, like, if weather's really bad, and that added, 20-30% to my travel time on the roads, something of that nature. I don't know how we're going to characterize this, but we'll get there. Okay.
Yep.
All right. I can work this a little bit more. We can come back and revisit that. How do you feel about that one so far? You get the idea of how this might work?
Yeah. Looks good. If anybody watching us wants to ask questions or wants to add something to the diagram, to the influence diagram, write in the comments.
Sure. Yeah. All right. So now, Alex, this has been a fun exercise so far, but now the work really starts. As a subject matter expert, you need to tell me what are the values that associate with each one of these yellow boxes, right? And one of the things you're going to have to decide is, as a subject matter expert, and I'm not going to say what it is, but how are you going to characterize that uncertainty? Let's just talk about the transportation time, okay? So a couple of ways you could do that. One way is to say, well, I know there's a minimum time, there's a most likely time, and there's a maximum time. And then we could use a triangular distribution to fit to that.
Mm-hmm.
On the other hand, you could talk about percentiles. You could talk about the P10, the P50, the P90. So it'd be only a 10% chance of being below the P10.
Yep.
And a 10% chance of being above the P90. And then you would say, here's the P50.
Yep.
That'd be another way to do that. Mm-hmm. You could, not typically done, but you could characterize it as just a uniform distribution. It could be equally likely anywhere in this range, okay?
Yes.
Something like that.
And people watching us, I mean, write what's your preferred method, and then I'll tell what I would feel more comfortable with in a second.
Okay. And then there are more complicated things. I mean, you could actually just draw a line on a chart, and or for example, you might say, hey, it's normally going to be in this range, but there's a chance it could be really much longer, so it looks more like a log normal distribution. You could just draw it on an envelope with some scales, and we could fit that to some sort of curve or resample from it or things of that nature.
Yeah.
Using metalogs. So
yeah, exactly. So
there's all kinds of options.
Something underneath. I don't know about you, Brian. My personal preference is I think I'm psychologically afraid of bounded distributions, which imply that it will be no lower or no higher than your upper and lower bound. And so if I had a choice, I would always go for P10, P50, P90, always allowing for this extra tails, because unexpected things happen.
Good point. In other words, when assessing the minimum and the maximum, really you need to stretch yourself in doing that. And Doug Hubbard has some training that he does on calibration.
Exactly.
That kind of helps people, because people tend to think they know more than they actually do. I mean, even in something like this, where you say, "Oh, I've been to the airport, 50 times, and I know exactly what it's going to be." Well, there's going to be one time that it'll be different from that. Well, one thing you need, go ahead.
No, sorry. That's a wonderful cross mention, because Doug has a workshop during the Risk Awareness Week, so make sure you don't miss it, because he'll sure mention something about calibration. I actually personally went through Doug's calibration training, and so we can argue that, statistically, I'm actually well calibrated according to the tests that we have done. So we can argue that I can use triangular distribution for this specific problem for this demonstration.
Yeah, you got to keep track of the fact that sometimes you lose that calibration too, unless you can remember all those little tricks that you learn about how to stretch yourself and not get too narrow in your distribution.
Listen, I think they've imprinted on my brain now.
Okay.
Client's pre-mortem and equivalency bet test and calibration multiplier. I think I have it kind of day and night.
Okay. All right. So
what shall we do in the interest of time, and kind of to make this segue into the second session that we will do on this topic? What shall we do now?
Well, I think there's two things. We could talk about a decision tree. Alternatively, I do have a I took the this is not what I want. Yeah, this is what I wanted. Yes. You gave me some numbers initially, okay? And for some of these uncertainties, and I started to put them into a kind of a structured model, and I got lots of holes here on what things are. So there's some work we have to do here, but maybe we do that in the next session.
Yep.
And
I think so.
yeah, okay. So that's what we're going to do, and then we're going to build out the model from this to make sure we know we've got all the components for each of the alternatives, the strategies we're going to do, and I think we've added some more of the strategies up here.
Yeah. So if I heard that correctly, once we've done the influence diagram, we can either do a decision tree, or we can switch, skip the decision tree and kind of start building the actual mathematical model that will allow us to quantify the alternatives.
Yeah, I think in this particular case, we're basically talking about having several decisions up front here, and we've identified those as these are the decisions, and there'll be a strategy that we follow, but these are the decisions we're going to make, and then we're going to have a bunch of uncertainties following that. And you saw all those yellow boxes that would then be following, and some would apply to certain strategies and some would not.
Mm-hmm.
So I don't know that building out this is going to be important. Where this is important, though, is when you've got uncertainties that are feeding a decision. Remember when we talked about those arrows switching around?
Yes.
That's really important. And then you might want to do that, and that kind of gets into the value of information. I understand that Risk Awareness 2020 has got some other presentations on value of information that people might want to watch.
The value of information is a hugely important topic, and make sure you don't miss a separate workshop on value of information during the Risk Awareness Week.
Yeah, and it's something that I agree is very important, and unfortunately not very well understood or applied. So learn it well. One of the things that we can do, kind of as you get towards at any point in time in the framing session or during the analysis, you can come back to what's known as the spider diagram. It was developed by SDP, excuse me, by SDG, Society. No, not Society. Strategic Decisions Group. Excuse me.
Yes, of course.
Too many acronyms. Okay. And so these are the six things that we need to work on to have a good decision quality. And so you need this appropriate frame. We've been working on that. We need to have doable alternatives. I think we do have several alternatives. We've actually added some alternatives during our discussion here.
Yeah.
And meaningful, reliable information. We haven't done much on that yet. I think we have some work to do.
Well, I think that's on me as the decision maker. I need to go back and research some of the information that we will use in our decision model.
No, it's not. I mean, I think it's something you need to work on. It's not like you're deficient here. We just haven't gotten that aspect of the problem. So no criticism to you. It's just something we need to work on next. And we've got some clear values and trade-offs. We've identified those alternatives. We haven't talked about, other than talking about your hourly rate, is a possibility of bringing time into the cost. That's fine. We need to be logically correct, make sure we've included everything that needs to be included in each of the modes of transportation. And then what's really important out of this, if you're not willing to follow what comes out of this analysis, we haven't gotten commitment to action. Because I've been in meetings as well, and I imagine others have as well, been in a meeting, make a presentation, and you get thanked very much, and you leave the room and nothing ever happens out of all that. You feel really bad about it. That's because we didn't get this commitment to action here.
So our objective by the end of next session to have a perfect circle across all 6 items.
That's the objective, to be out here at 100% on all of these. But sometimes you've got to ask the question, it may be too much effort to get to that last little bit. So you have to decide when's sufficient. And one of the other things, this is actually a criticism of decision analysis, is paralysis by analysis. You want to make sure that you do the appropriate amount of work for the size of the problem, okay? And the time you have available to make the decision. And so sometimes during this, if a good framing session sometimes will just lead to a natural answer, and you don't need to do the analysis and the model building and the probabilistic. But oftentimes that obvious answer doesn't pop out, and you need to do some analysis. But just make it appropriate for the size of the problem you're looking at.
I mean, it's a very important hypothesis. Let's test that. Everyone who's watching us, write in the comments underneath, what do you think would be the correct answer, the most optimal mode of transportation to and from the airport? And then let's see how that compares to what our calculation shows at the end.
Okay, that'll be a good test. There's going to be a lot of uncertainties in here that they're going to have to make. They're going to have to make some implicit assumptions about some of your variables on the costs and how you value your time on a train or in a taxi.
Yeah. Well, if we were to ignore all of research ever, then we would think that our intuition is a good judge when making decisions. And let's see how well the intuition of our listeners works when the uncertainty is high. I mean, there are a lot of variables, and let's see how you can you put it together in the way in your mind that will be comparable in terms of quality of the final decision to the actual framework.
All right. Anything else you'd like to do today?
Knight, silver, all claim you can't, but let's see if some of our listeners can.
Well, they may have done this analysis themselves, so. Although it'll be different input data, it's different value, and different risk tolerances and value measures that they might have been looking at.
Exactly.
Well, anything else you'd like to do in the framing at this point in time, Alex?
I think we've done wonderfully. I think this is a good start, and it's a good segue into the next session where we will do some research on the actual meaningful and reliable information. And we will start converting the influence diagram into the actual probabilistic model, and then we will put all of this together. And in the next session, Brian and I will discuss how we can actually build the model and how we can run the simulations, and we will demonstrate some of the exciting features in SIP-math. So that will be a win-win-win. Don't miss the next session.
Yeah, well, I'm hoping to show you some fairly unique ways of analyzing this particular problem, so we can generate insights. Because one of the things you want to do in decision analysis and decision quality is generate those insights. Because oftentimes the decision executive will have his own perception of what the right answer is, and what you need to do. Not that he's saying you've got to come up with this answer, but he's got a perception. That's why you want to include him. Or them, could be a female as well, but you provide insights that say, oh, I hadn't really thought about that, and maybe I understand why this analysis is coming up the way it is, and that allows him to better assess the ultimate decision he's going to make based on the analysis that you've given him. And he may not agree. There may be some other external factors that he has that he hasn't really shared with the team for various reasons that causes him to do something different. But at least you as the analyst, you've done the right job in presenting something that's very understandable, and something about storytelling. This is really important. Is you need to be able to tell it as a story. Don't just throw up a chart and say, well, here's the answer, and expect him to understand that. You need to be able to tell a story around each of these graphics that you might present.
Sounds good. Perfect. Well, thank you everyone watching us. So if you have questions left on the first part of the journey into decision quality framework, ask away in the comments underneath, and we'll see you in the next session.
Thank you, Alex.